All right. And we're live. Welcome, guys. This is a weekly, bi-weekly, depending on how many hackathons we're participating in. Winners Demo Day live stream. So super excited to be with Josh and MD. These are our two winners from the recent OSCAFEST hackathon. So my name is Kate. I'm the community lead here for Axelar. If you've watched any of these streams in the past or hopped on any ecosystem AMA, you probably know about me. I run the Telegram, the Discord, so probably a familiar face there as well. So enough about me. I'll love to introduce our two winners. So I will start in order that I see you guys. So Josh, or other way. Josh,
Very good.
want to introduce yourself quick?
Yeah, my name is Joshua Adesonya. It's great to be here. I am a software developer and a blockchain developer as well. I started my career as a software developer, initially front end, back end. Then, I think around 1 or 2 years ago, I I was able to see what was going on in blockchain industry, and I felt it was interesting. So I opted on it. So I currently work at Baker Industry. It's a company that deals in real estate, farm. But they also do it work a little bit in blockchain. That's what I do there. So I work in blockchain and also build their software, website, and other things in between for them. So that's where I currently work. So yeah.
Awesome. All right, Namdi, you're up next.
All right. Jim, everyone. My name is Nnamdi Ume, a software engineer from Lagos, Nigeria. I'm also a technical writer. Um, I've been developing software professionally for the past 4 years, and just until last year, I started, I delved into the world of Web3, and yeah, glad to be here.
Nice. Well, glad you stuck around. These past 4 years have definitely been interesting in the
Yes.
Web3 world. So unlike most other hackathons that we participate in, this one was in person, right? So you guys were all in person for the hackathon?
Yes.
Awesome. Well, without further ado, let's get started into some of the demos of what you guys built and how you used Axelar in your code. So, Namdi, I'm going to tap you to go first. So I'll remove myself and Josh from the stream. If you want to share your screen, and you can take it from here.
All right. Thank you very much, Kate.
We'll get your screen added, and then I will pass it off to you.
Yeah, I'm currently sharing.
There we go. All right.
All right. All right. This is SUVe DAP demo. For this is my entry for the Axelar OSCAFEST hackathon, and a quick. Okay, I've already introduced myself. I'm a full stack web developer and technical writer, and this is, I'm very glad to be here to present the my demo app entry. And so the problem. So I'm introducing SUVe. SUVe is a decentralized interchain app that allows users to verify the authenticity of vaccines. And one of the major problems of supply chain business is counterfeit, and most especially in the medical field. Given the pandemic that happened about 2 years ago, we saw a spike in counterfeit vaccine, and I thought, to myself, how do we solve this problem of counterfeit vaccine? And so I developed SUVe. So SUVe, like I said, is an interchain verification application. It basically means super verification. So it is a verification mechanism that utilizes Axelar under the hood to enable the interchain feature. And you might be wondering, why Axelar? Why is Axelar critical to SUVe? Most Web3 users always interact with protocols on their preferred chains, and one problem with that is that every application has to be deployed across multiple chains to, allow different users on each blockchain ecosystem to be able to use them. And so Axelar helped, it helped, to allow this application work seamlessly from any blockchain. So this is the architecture of how SUVe works. There's a DApp, the SUVe DApp. that is connected to this mechanism. So the enrollment contract is basically the single source of truth. This is a contract that allows the enrollment of vaccine, and then the verification contracts are used for verification purposes across the different blockchain. And this verification happens, the interchain verification happens through GMP, that is the general message passing from Axelar, that allows users to enter a particular vaccine ID, and then that vaccine ID is routed through to the enrollment contract and then confirmed. And once it has been confirmed, the message is also passed down to the verification contract as well, and then the result is displayed on the interface. And so, without further ado, let us see how Axelar powers SUVe and then get to understand the app better. Now, this is the interface for the enrollment. This is where the vaccines are enrolled. Now, in a typical scenario, let's say in a vaccine assembly plant, this would be done with an API endpoint that is connected to SUVe. But for the purpose of this demonstration and to make it easier to understand, we are going to manually fill the form, and then we'll see how users can verify their vaccines. So let's assume we want to enroll a vaccine called, we can enter any arbitrary name. So I'm going to just use Shield Max COVID booster. Now this is an arbitrary name, not a real vaccine, but for demonstration purpose. So right here, we'll enter a short description. So I'm just going to paste in something I've copied into the form. And then we can upload the vaccine image. And this image is uploaded to the to IPFS. So once that image is uploaded, we can select when the vaccine will expire, and then we enroll that. This is going to propped up MetaMask to allow us to confirm the transaction. And once I confirm the transaction, that vaccine information will be persisted on the blockchain. And here we have the information, Max COVID booster. Now, let's assume a health institution wants to verify the vaccine. They've gotten the package, and then they want to confirm whether this vaccine is authentic. They can come on the platform and enter the vaccine ID. This is assumed to be packaged with the vaccine, but here I will just copy the vaccine ID and then I will paste it. So there's something we can notice here. We can see that there's a gas estimate. The vaccine was the vaccine that we just enrolled is on the Avalanche testnet, as you can see here. This is the Avalanche is on the Avalanche testnet, but we are verifying from the Phantom testnet. So the application allows users from different blockchain ecosystems to be able to verify their vaccines, and this gives gives amazing benefits, like users do not have to switch to their they don't have to switch to different chains in order to verify. And then they can leverage on any pros, like for instance on the Arbitrum network where it is fast, and then they also enjoy the security of Ethereum. They can prefer to verify the vaccine from such platform. And so once they enter the vaccine verification, we discover that there's a gas estimate. Axelar, this uses Axelar SDK to calculate the amount of gas that will be needed to interact from Phantom to the enrollment chain. And in this case, it is 1.489 FTM. So when I click on verify, it will prompt up MetaMask with that same amount, which is here. And then when the user confirms it, it starts the verification process. So as we can see, it has already started the verification process. The verification has already started and it has been confirmed. So what is happening right here is, in order to explain this, let me pull up the mechanism image. So what is happening here is that the vaccine was was enrolled on the enrollment contract, and then let's say a health institution that wants to verify the vaccine that is connected to any of these supported blockchain can easily check whether check the authenticity of the vaccine. So what is actually happening is that I enter the vaccine ID on the DApp, and that DApp connects to the verification smart contract on FTM. And then from FTM, from the verification smart contract, it passes the ID of the vaccine to the enrollment contract using Axelar GMP. That is the general message passing. And then when it verifies the authenticity, it sends a response back through GMP again to the verification. So what actually happens here is a two-way GMP message, GMP, two-way general message passing. And so that is exactly what is happening on the front end. So we can see the state of the transaction by clicking on this tab, and that's going to open the Axelar scan. So from the Axelar scan, we can see that there has been a successful connection from Phantom to Avalanche, and then the response is currently underway. So clicking on the callback, we can open that response to see the status. Now we see that not just that our vaccine ID has been sent to the enrollment contract. There's also a response back to our to the Phantom network, and all this status is being tracked on the front end, and that is why we can, the users can see a feedback that shows how, what is happening under the hood. So after validating the hash, we are going to have our vaccine information here. So this is basically how SUVe works, and it is supported across multiple chains. We can confirm vaccines from Celo network, from Polygon Mumbai, and from Avalanche. So we can see that the vaccine ID that we entered has successfully, been sent to the enrollment contract, and then the result is rendered on the front on the web page. In the event that a user enters a vaccine that is not coming directly from the manufacturer of the vaccine, it is going to alert the user that this vaccine is not verified, and the person can take appropriate measures to ensure that such vaccines are not administered. So this is how SUVe solves the problem of counterfeit, and in this case, vaccine counterfeit. But SUVe can be extended to across multiple businesses like the automobile, the fashion industry, and so on. And this is basically how it works, powered by Axelar. Now, in order to proceed, let us see how what happens under the hood. How does SUVe uses Axelar to solve this problem? On our contracts, on the contract folder, there are two smart contracts: the vaccine enrollment and the vaccine verification service. Now, the vaccine verification services extends Axelar. So this is what makes it have the interchain magic, the interchain verification that is enabled by Axelar. And so the two most important functions here are the verify function. So on this verify function, it accepts a hash, and this hash is what is entered from the interface, this hash here. And so once the call is made, that hash is encoded as a payload, and the gas fee that was gotten from the Axelar SDK is sent to the gas service. And so this gas service basically pays it converts the chain on which the user is trying to verify it. It converts the local token to the enrollment what's it called, the enrollment service token. So because we are making a call from Phantom to Axelar, it converts FTM to because we are making a call from Phantom to Avalanche, it converts the FTM token that we are sending to EVAX token. So that is basically what is happening here. And then it calls the enrollment function, which in turn, so when it calls the enrollment function, I'm going to switch to the enrollment service so I can explain what happens. So when it calls the enrollment contract, this execute function is called. And what happens is it now decodes the payload, which is the hash that the user is sending, and the address that is sending that is making the request, and then it verifies whether that hash exists, and if the hash exists, it now it now encodes the vaccine that is associated with that particular hash and sent as a response. And it is that response that is now displayed on the front end of the app. So this is basically how SUVe works. Yeah, that is basically how it works. Thank you very much. And if there's any question, I'll be really glad to answer them. Thank you very much.
Awesome. Thank you so much for that super comprehensive walkthrough and demo of what you built. So have you hacked on any of Axelar's bounties in the past, or is this your first time working with Axelar at a hackathon?
All right, this is actually my first time, and I must say the experience was amazing because there was a point in time when I tried to, perform an interchain I wanted to create an interchain app, and it was really difficult. But with Axelar, this it makes it very easy. At first, I did not understand the documentation, but thanks to the amazing resources on the YouTube, because I'm more of a visual learner. So I went to YouTube, checked the videos, and it brought me up to speed. And immediately I got a hang of what was happening. I was able to understand the documentation perfectly. So I must say, Axela, thumbs up for this amazing protocol.
Awesome. Well, yeah, that's great feedback, and that's also why we like to run these kind of events, right? The streams, so that people that are thinking of building, thinking that have people that have hacked one of our bounties before and are kind of getting inspiration, for what they can build in the future. Just another resource, like you said. Some people are visual learners, some people just like to work through the documentation. So again, thank you for this really comprehensive kind of overview of what you built, and also the deep dive into the GitHub. That was super helpful. So we are going to move on to Josh, and then I'll bring everyone back at the end to kind of wrap up. But I'm going to bring Josh on stage. So thank you again. We'll see you in a bit. All right.
Yeah.
All right. So if you want to share your screen, I can get you connected, and then I will hand you the floor.
Okay. Okay, it's done. I think I just shared my screen.
There we go. Oh, we got a screen inception. There we go. All right. So
Can you see my
pass
screen?
it off to you.
Hope you can see my screen now.
All good.
Hello, can you hear me? Can you see my screen?
Yep, we can see your screen and we can hear you. You are good to go.
Okay, thank you. Yeah, so like I said, my name is Joshua. I built DePay, but I renamed it to Intersend. So let me just get straight into it. So the reason why I built this app is if you're familiar with the terrain in Africa and even in some countries around the world, the major problem that blockchain crypto solved is uh, payment in the sense of sending payment across. So initially, before blockchain became popular, before crypto became popular, for you to send money from one continent to another or from one country, interborder payment, it's a problem. You have to go through a lot. Banks will put you through a lot. People will put you through a lot. Sometimes you may even lose your money. Sometimes your money may get stuck. And it's when blockchain came into the limelight, it really made that easy. So you can easily send crypto to anyone anywhere in the world without any problem. In seconds, it's done. And that was very, very good. But later on, we started having a lot of chains. We have Ethereum, we have Polygon, we have Avalanche, and now it's another problem. It's coming up. Now you have money on Ethereum and you want to send it to someone, but the chain that the person uses or the person is familiar with is probably Polygon or Avalanche. It's kind of presented another problem, and sometimes you need to go through swap exchange. You need to swap it before you get. And the major problem that we have in the crypto world is that the user experience is quite poor, and that's why we're having problem actually onboarding users. People want something that they can just in few seconds they are done. They don't want nobody wants to use an application that adds more problem. And that was these are some of the reasons why I actually built this. So this application is quite simple, not really complicated. It's about sending crypto to others in just one click. You get, without any problem, without trying to have any know anything or any extra knowledge. So I'll just run us through it basically. So this is the first page. This app basically does two things. Although I'm trying to add that feature to it to make it better. But currently it does two things. The first one is send crypto across chains in as fast as possible. So as you can see, the first box is AUSD because that's the only token currently supported. But I'm planning to add more tokens to it so you can be able to select any token you want. And then the second box shows your current balance of that particular token. So currently you can say I have around almost 170 AUSDC. And then I can select the chain I want to send it to. So currently it's supported by around 4 chains: Polygon, Avalanche, Binance, and Celo. And if you look at the top of my app, I'm currently on the Binance Smart Chain. That's where my AUSD is currently. But I can decide to say, oh, I have someone that it's on, let's say, Avalanche, and I need to send a token to someone on Avalanche. The normal procedure would have been for me to swap or move my token to Avalanche somewhere else. Then I go to Avalanche, connect to Avalanche, then send it to the person. But now I don't need to do that. All I need to do on this app is choose Avalanche, pick an address. Let me just use my address for testing purposes. So put the address and the amount I want to send. Let's say I want to send 50 AUSDC. There's no need to swap. There's no need to do anything. And the basic process that we do for all crypto transaction, the first thing you do is approve, then you send. So let's go straight to the demo. So let me just approve the smart contracts to be able to send this. So it pops up MetaMask. I use my default 50 AUSDC. Click on next, approve. And once the approval is successful, I click send, and immediately after a few seconds, I can be able to get the token on Avalanche. So let me click on send now. Okay, so this is the actual transaction. This is quite normal. Well, in the future, we try to make it to just one click. But for now, we just go through a normal crypto process, approve, then send now. So once we send now, and it goes through, you're going to get a notification that it's going to be finalized in a few minutes. So because of the bridge, which is Axelar that we have, it needs a few seconds to be able to finalize the transaction, because it's not quite instant. And we can see that on the Axelar scan. So yeah, we can see that. You can see 50 USDC from BNB chain to Avalanche. So it needs a quiet. You can see the sent, gas paid, confirmed. It's currently in the approving process, and it's quite fast, I may say, from BNB to Avalanche. In max of 1-2 minutes, you should be able to see your token on Avalanche. So that's really my my goal, just to simplify the process, because if our goal is to onboard people on Web3, on blockchain, the way to bring them in is to make their life easier. It's not to build complicated apps. It's not to build or something to dazzle the blockchain communities. It's to bring in novice people that just want to make their life easier. And in Africa and in some other continents, what they need is to make their life easier. And I think this app and many other apps out there are doing that. So in a few minutes, once it finalizes, I'm going to show us on, I'm going to log back into Avalanche, and we're going to see that the token has landed there. So while this is still running, the second one that I want to demo is the payment link. So this actually just is like a direct, you're sending crypto to someone directly. There's no complicated thing about it. The other one is the same, but kind of more interesting. So let's say you have there's someone that you want to receive a payment from, or there's someone that needs to pay you. So instead of the person going through the hassle or the problem of trying to log in, trying to set up things, or trying to do anything just to pay you, all you need to do is just copy the payment link and send it to the person. So once you send it to the person, you have something like this. So basically, what does this do? This basically is a link that shows a page whereby your address is auto-filled, your chain is auto-filled. All the person needs to do is enter the amount that the person wants to send to you. And as you can see on the link I sent, the recipient address is there. The recipient chain is Polygon. So all I need to do now is just input, let me use 20 AUSDC. So all I need to do is just input the amount I need to send to the person. Let me just run on so it's not confusing. So where I copy the link, that's the recipient, that's the owner of the payment link. So I have to send it to someone else that wants to make a payment to me. So this is the view of the person that wants to make the payment. So, and it can be from any chain. And as you can see, the initial chain of the recipient is Polygon, as you can see on the UI. But the person can actually, the one that wants to actually send the money to you can actually send it wherever, from Polygon, from Cello, from Avalanche. But for the purpose of this demo, I'll just send it from Binance Smart Chain. And the process is the same. You just need to approve the transaction. So approve the transaction. So after the transaction has been approved, and then we can be able to send the payment off. So let's use this minute to just check our transaction if it's still running. The initial one that we sent. Yeah, that's done. You can see we have been able to successfully send 50 AUSDC to Avalanche. And although I didn't show us the initial, I didn't show us the initial balance on my Avalanche, but yeah, I can assure you that that has been sent. So for the other one, the payment link, since the approval is successful, you can click on send now and confirm the transaction. And just to make the UI easy, you can see the gas fee. You can see the token that you're sending the gas fee in, just to make the user experience. Like I said, the purpose of this is to make life easy, so there's nothing hidden. You can see the amount of gas fee they're about to send in the in your token in which you're trying to send it. So you know everything that is currently happening. You can calculate the amount you're about to spend on the transaction that you're about to do. And if we check the Axelar scan, we'll see that the second transaction has started running, and in few seconds it should be able to run through. Okay, let me just quickly go to the Avalanche. As you can see, we have about 225 AUSDC on Avalanche, and part of it is actually the 15 which I sent. Like I said, you can do this from any chain. From Avalanche, I can also decide to send to any chain down here, and everything goes through. So the third feature in which I'm currently working on is the request feature, whereby anybody from any chain can request money from anyone. Very, very simple. You request, and the person on the other side accepts the request, and everything goes through. Okay, so let me quickly run us through how the code looks like. Before that, let's check if our transaction on the payment has gone through successfully. Yeah, it's now successful, and we are able to confirm that. For this Polygon own, there is an history, so we can actually check that. You can check the history on the payment link. Hello, can you see my screen?
Yeah.
Let me refresh. Okay, so there is an history whereby you can be able to see the amount sent, the sender and the receiver on the payments page, where you can also click the payment link. So let me quickly run us through the code. This is the code. So I have two contracts. I have the receive contract and I have the send contract. So the send contract is the one that works for the first one. So that's basically the one that we use to send to any chain. You can send money to any chain basically. So we have the send to many function. So the send to many function is a function that we call initially on the chain that we're calling from. So if I am on Binance Smart Chain and I want to send to, let's say, Polygon, the function I'm actually calling is the send to many function. So that's the function I'm calling. Then the second function is the execute with token. So the execute with token is the function that calls on the receiver contract. So that's the contract in which you are trying to send the token to. And the code is, this is basic Axelar code. You send it, you input the destination chain, the destination address, the symbol and the amount. And on the execute token, it basically runs through the addresses and sends it to the right place. And the other code is the receive. That's the receive contract. The receive contract is a little bit more customized because we're trying to get some information as regards who sends the money, who is receiving the money. So the code was a little bit customized. It's still the same send to many and execute with token contract, but we also have pay history where we're trying to track exactly who sends the money, and we're trying to save the records on the blockchain so that you can be able to because the receive contracts can actually be used for different purposes. You can use it for your business and say, oh, I'm sending my payment link to other people. So you need a way to be able to track. Although it's a blockchain, you can go on chain, but like I said, the aim is actually the user experience to make sure that people do not have to overexert yourself, stress yourself unnecessarily. So right on the app, you can be able to see who sent the money to you, and you can be able to confirm that, oh, you have received that particular amount. So that's really all. There's no more. It's not really complicated. It's very simple. It's just to make life easier for everyone. So I don't know if anyone has any question. Let me stop sharing.
Don't see any questions from the stream, but I mean, I'll ask you the same question that I asked Namdi: is have you hacked on one of Axelar's bounties in the past, or was this your first time?
Yeah, this is my first time.
Nice.
This is my first time. Yeah, it was actually a very, very great experience. I actually started initially, and I had to stop because I didn't have enough time to actually run through documentation because of my other engagement. And then I got a message from a friend that, oh, they have extended the deadline. So I decided to just have another check on it, and it's very, very good compared to other cross chain. Because currently now we have a number of other cross chain. I can say that Axelar is actually the best out there. Very simple, very straightforward. I just had to look at the documentation, and I was able to actually get everything that was going on. It was very, very smooth.
Awesome. Well, we love to hear that, and clearly it worked out since you're one of the two winning projects from the OSCAFEST Hackathon. So just to wrap up here, I'm going to add Namdi back to the stream. Here we go. All right. So thank you guys for that really, really great walkthrough of not only what you built, how you built it, but also how you integrated Axelar into the code to power both of your wins. So, for anyone who's interested in getting involved with hackathons and following along with which hackathons Axelar is participating in, you can follow us on Twitter. We're always active there and letting people know which hackathons we'll be present at. We also do have a dedicated hackathon channel in our Discord as well. So make sure to join Discord, grab the builder role, and you'll be able to see the hackathon channel there. You'll also be able to see the live stream here anytime on YouTube. And we will be posting a blog post breaking down both of these awesome projects, as well as the links to their demos and their GitHub. So that'll be live next week. So big thank you again to both of you for joining the stream. For showing us what you built, and again, congratulations for for being the two winners of Axelar's Bounty at the OSCAFEST Hackathon.
Thank you.
Yeah, thank you very much.
All right, so we will end the stream there. But yeah, hop on our Discord, join the Telegram, follow us on Twitter to keep up with what we're building, and congrats again, guys.
All right, take care.
Bye.
Bye.
Yeah, thank you.